That way I can post this part here. And that way you can find it online in case we need to go back to it. Now, let's see, plane K, J, and L. And then here we have intersecting lines. So two lines intersect at a point. So the example I use for this one is kind of like a string. Now I can't find my other string that I had. All right, but if you could imagine, if I had two strings, they are going to intersect at some point. Maybe if I had like a pencil, that'll work. Right? There's only gonna be one spot where they're actually gonna be touching. I can't make these lines touch in more than one spot unless I put them right next to each other, like to where they're always the same line. But if they're in any way pointing in any different directions, it's always gonna just cross at a single point. So two parallel lines, and for the next one we have intersection of a plane. Now you might have if you've ever played a video game, sometimes they have like a glitch or something, and you'll have like two solid objects and they just kind of go together, and then they kind of have this thing where, you know, they're both together, but you know, they're occupying the same space. So that's kind of like what it is. If you can imagine, these are like ghost thingies, and they can just go right through each other, right? So if they can go right through each other, then they will cross at a line. So here we have line K that is going through both of these planes. And remember, these planes are not just like pieces of paper. They go on indefinitely. As it says here, the plane goes on indefinitely. So even though these are, like I use the example of paper, that doesn't mean that they are exactly like paper. Okay, and naming points and lines. And I'm going to go back up a little. Well, there's only two things you need to write in that case. So again, if you have your packet, go ahead and follow along. If you don't, you could probably try using writing this down in your notes as best as you can. I will post this video later. In fact, probably once I'm done here. It takes about an hour for them to get posted, but you can find them, go back and fill these out whenever you get your packet. Probably the best way to get your packet would be to come into the building and pick it up, I think is how we're gonna do it. I think we are also gonna mail them out, but if they get mailed out, it could take anywhere from a week or even a couple of days for you to get them. And in a time like this, we really don't wanna be wasting a whole lot of time waiting for packets to come in and stuff. Because I know that was one of the things that happened even during the spring semester, was a lot of students were saying, I didn't get my packet yet. You know, it takes like a month or something, or I don't know, not a month, but maybe like a week or something. But it can take a while. So make sure you get your packets, and I know we'll probably have to come up with some way of you getting them. So anyway, here's more of the in-class work. So we have Corp 5. It wants us to name 4 collinear points. Now it also says answers may vary, so they're not all going to be the exact same thing. So some of these you could come up with other ways to name these, and I think for most of these it's going to name them in the most common way or the simplest way. So here we have 4 collinear points. So again, collinear means on the same line. So we've got to find 4 lines that are on the same line. And if I try M and O, well, that's only 3 of them. So that's not going to do us any good. I could go JKL, same thing, only 3. So the only one that I can pick that has 4 is HNKI. And it already has them listed here. So you can see that those are the collinear points. Now a line that contains point M. So this is the next question. So let's look at M. And now we need to know what the name of the line that is. Now, again, answers might vary. So you could put line MN, you could put line MO or NO. Then those are 3 other ways you could do it. But here it gives us, again, the simplest way is to just say line P, which in this case here, since the name P is already on that line, let's just leave it like that and move on. A line that contains point H and K. So here I have H and K. And it says to name the line. So in that case, the line will be R, and that's going to be this one right here. That means this whole line here. So I don't need to call this line HN, HK, HI, NK, NR, NI, NH. You know, there's a bunch of different ways we could say that, but line R, simple way. And here it says to name another name for line Q. So Q is this bottom line here. And since we can't use Q, we're going to have to come up with the other ways, and that is to pick 2 points. So JL, that's the longest one, but you don't have to pick the longest one. You can also pick some of the shorter segments like JK, which is this one here, and then KL, which is this one over here. So those are the 3 ways that you can name a line, you know, if you can't use its 1-letter name. So the intersection of lines P and R. So P is this top one, and R is this almost vertical one. So where do they intersect at? Well, that's kind of easy. And again, intersection, just like if you can imagine these as roads, right? If this was a road, they would cross in an intersection. So you'd have a stoplight, usually. You might also have a stop sign. Or if you're a weird group, you could probably also have a roundabout. Personally, I don't like roundabouts. I don't know. I don't like that there's a big spot in the middle that just is for nothing. I mean, or like if you've ever been in a roundabout, like sometimes it's hard to get out of them. So you have to go all the way around to try to get out again. Or you get people that don't let you in, or you get people that cut you off while you're in the roundabout. I'm sure there's one roundabout you probably all know about where that's happened. I don't know. For me, stoplights are fine enough. Anyway, so there you go. That's the N part. I'm going to go ahead and move on. Let's see, diagram to name the following. So here we have a plane with 2 lines. So one line is going through and the other line is going along the plane. So a line containing point F. So here I have F, and it wants a line on there. So here is that line. And it gives us a nice, easy way of naming it. We could just name it line J. So that's easy enough. Just name it line J. We could also name it something else. We could also name it DF, EF, DE. So, but again, let's stick with the simple and most common ways. Another name for the line K. So that's the next one here. So K. So here I have K, and that's exactly what I just got done talking about that one just now, because we could name it with any of the points. So BE, BC, and EC. So those are the other 3 ways, is to just pick any 2 combination of points along that line. All right, so let's go and move on to the next part. So this would be a plane containing the point A. So here I have A. And again, I could also name this with any 3 points along this, but since it tells us here, and it's marked with this, I don't want to say it's cursive, but it's kind of fancy. I don't know what font that is, but it's kind of that fancy looking M. And that usually means that it's a plane. So again, uppercase for points, lowercase for lines, and fancy for planes. So there you go, plane M. So plane M also contains A, D, E, F, and line J. So those are all the figures that are on plane M. All right, another example of 3 non-collinear points. So anything that is not on the same line, so non-collinear, so not on the same line. And the example it gives you is A, B, D. So there's point A, B, and D. So A and D are coplanar, and they could be collinear, but if you add B in there, that's way off up here, and that's not at all, you can't make any line go through those. So since you can't make a line going through those, well, they're not collinear. And again, this is kind of like if you can imagine it, it's kind of like a piece of paper, and then we have a string kind of like pushed or pulled through it. That's kind of what it's like. So I know sometimes I get people asking about that, but yeah, that's what's going on. All right, so number 3, moving on to number 3. And normally I don't I don't check my mail. But I'm just gonna go ahead and scooch over to my mail really quick and but I know that since this is the first day, I know that there are some students that are trying to get into the class and trying to get all, you know, trying to get to know where to go. Oops, so I'm gonna go ahead and take a quick break. Not just to get this all sorted out. Just so that way I can make sure more people are where they need to be here, less time wasted. Now this thing's not quite working out. All right, there we go. I'm back. All right, so back to here, name 3 coplanar points. So plane, again, is formed by any 3 points. So V, Y, X. So let's go ahead and find out where V is. So V, Y, X. Now, if you can imagine it, this is kind of like a pyramid on a piece of paper. The piece of paper, we're going to name that R, and V, Y, X. So these are all on the same plane. And you could come up with something else too. You could come up with VWX or XWY or any combination of these 4 points. So again, you don't have to pick exactly what I'm showing here, but you can pick some in any points along that. A plane containing point X. So next one here, plane containing point X. So here, wait, is that the one we just did? I think that is the one we just did. I think I read the same question over again. Intersection of plane R and ZVY. ZVY. Now it's asking plane R, so that's this flat sheet here, and then ZVY, which is, if you can remember, this is a pyramid, but it's that far wall. It's this wall right here. And VY, that is the intersection. So you have a line segment. Okay, so this is a line segment, not a line, because it's a short piece and it stops. And you can see that it stops from here to there. It doesn't go on forever. So that's why we mark it as line segment, VY. All right, so yeah, that's where they come together. So next one here is how many planes appear in the figure? So a plane, again, remember, it needs at least 3 points. I'm going to jump up there again. So any 3 points make up a plane. Remember, that was one of the definitions that we had. So here I could also pick something else. I could pick like this ZYX, ZWX, ZVW, ZVY. So those are 4 of them. So the pyramid has 4 sides. But we also have the plane R. So that's the 5th one. So there are 5 sheets. Like if I had to make this figure in real life and I had like cardboard or something, I would need at least 5 different pieces of cardboard to make it. How many points contain the point, sorry, how many planes contain the point W? Okay, so if we look at it here, we have plane R, that's the easy one. It's just this bottom piece here. But we also have this W, so we could pick ZVW and ZWX. So all of those 3 contain that point W. Okay, so that's it for that one. Let's move on to number 4. And then use the diagram to the right to name the following. So number 4, the intersections of line L and M. So there's L, it's this one here that's kind of going through both of these. And then M, so I have this long piece up here, this line here. Now, there's a couple of things going on with this, and that is these 2 planes, they look, to me, they look parallel. So if you can imagine, like in my classroom, you know, there's a whiteboard behind me, and then there's a whiteboard in front of me. And that makes it so that they are two whiteboards that, you know, if they were really big, like infinite size big, because they're parallel, they would never intersect with each other. So that's what I'm guessing is going on here. But anyway, back to the question. Line L and M, they intersect here at E. So there's LM, or L and M, I should say. M is this one, and L is this one here. So that's the only place they intersect. Now here it says another name for plane Q, and I know that that's a Q. All right, it's written in a fancy way, but that's what it's supposed to be. Another name for plane Q. We could call it any 3 points on there. So in this case, they picked IFG. So IFG, and again, any of these 3 points would work out, except for maybe FEG, because since they're a line, they would not really form a plane. They would just form a line. So any of those would work out as long as it's not FEG. Now, are points D and E collinear or coplanar? So let's go ahead and look at D and E. Now, if we look at them, they're not on the same plane. So it's like, again, if I had a dot on one whiteboard and another dot named E on the other whiteboard, they're not going to be on the same plane. But they are on this line L, so D and E are on the line L, and that would be collinear. So that would be collinear. How many times do planes P and Q intersect? And again, like I said, if these whiteboards were infinitely sized, since they're perfectly parallel, I don't think they would ever intersect. So we're going to say 0. And if you look at the angles on all the sides, it does look like they would be parallel. So that's it for that one. And that's actually it for the in-class work here. So for this one here, I think we're going to continue on some of the homework, and we're going to cover some of the, on occasion, we're going to cover some of the homework in the class as well. But I am a little bit over time today, and that's probably something that's going to happen less often as we go through, because this is the first day of summer school, and you know, sometimes people just need some time to show up to know where to go. And I should have about 1, 2, 3, 4, 5, and you know, somewhere between 5, or I should have somewhere between 6. I should have somewhere between 7 and 10 students, but I only have 3 here. So yeah, that means that there's a lot of people missing. So I'm gonna have to go track those guys down and see what's going on with them. But yeah, you got to go to the Zooms. You got to, you know, be in the class. We're not doing the check-in thing anymore. So you got to make sure you're showing up to every day. And it's not really that long. 4 weeks and 16 days. You know, that's not too bad. 16 days. You know, it's gonna be gone and here like that. And you have 3-day weekends too. So you know, you got Friday through Sunday off, and you only have to work 4 more days. Well, 4 days a week, and that'd be 3 more for this week. So it's honestly not so bad. So since there's only a few days, since there's only 16 days, we got to make sure everybody is here, you know, because in a normal semester, you would have something like, let's see, wait, there's 9 weeks, there's about 18 weeks. 18 weeks of school, and that's a lot. So 18 times 5, and that would be 90 days, right? So 90 days is a lot of days to go to school, I guess. But you know, 16 is really nothing compared to that. But you know, in a normal school year, you could miss 10 days, I think is what we say. We can miss up to 10. That's like 1 out of 9 days. But you know, for summer school, there's not even 18 days. So you couldn't even miss half a day technically. Anyway, so that kind of brings us to the end of our, I'm the end of the lesson, but like I said, after this, I'm gonna continue a little bit and go over the homework so you can get some free stuff. And that's where it pays to have the packet in front of you. And I know probably most of you don't have the packet in front of you. So, I don't know, you could probably come up with some other ways to do this. I'm sure if you're tech savvy, you could really figure out some ways to save some of this and use it later. anyway, so that's it for the lesson. And like I said, I'm going to go on answering some more questions later. So that'll be it for this one.